All right, Chapter 7, Problem 27. Use energy considerations and ignore air resistance. Show that a rock thrown from a bridge 20 meters above the water with an initial speed of 15 meters per second strikes the water with a speed of 24.8 meters per second, independent of direction. Right? Independent of direction. So, what does this mean? So we want our initial kinetic energy plus our initial potential energy, right, equal to our final kinetic energy. Our final potential energy is 0 because we're now down at the water. All right, what is initial kinetic energy? Well, that is 1/2 mass times the velocity squared. Initial velocity squared, right, is 1/2 of the mass. Don't need to know the mass. It's going to cancel out everywhere. And the velocity is 15 meters per second squared. Let me put a times. All right. And what is the initial potential energy? Right? Is the mass times our friendly 9.8 meters per second squared times the height. And the height is 20 meters. Right? And what is the final kinetic energy? Final kinetic energy is going to be 1/2 times the mass, right, times, and we're given a 24.8 meters per second. All right, now kinetic energy, initial kinetic energy plus initial potential energy equals final kinetic energy. We have mass, we have mass, and we have mass. It's going to divide out everywhere. Our equation is going to be 1/2 of 15 meters per second squared plus 9.8 meters per second squared times 20 meters equals 1/2 of 24.8 meters per second squared. All right. Now, if this holds true, then the statement in this is correct. It doesn't matter what angle you throw this rock at. As long as you throw it at 15 meters per second, it's going to hit the water at 24.8 meters per second. Now, the angle it's at when it hits the water will be different depending on what angle you throw it at from the top of the bridge. So let's get all these numbers. 0.5 times 15 squared, 112.5, 9.8 times 20, put an equal sign in there. So 112.5 plus 196, right? All right, on one side here we have 112.5. This is going to be meters squared per second squared plus, what was the other number? 196 plus 196 meters squared per second squared, and our total there is going to be 308.5 meter squared per second squared. All right, we got 308.5 on one side. All right, and if the other side is the same thing, then we're good. So the other side is 0.5 times 24.8 squared is 307.52. So I think given all of our rounding and everything, and we're in good shape, right? 307.5 meters squared per second squared. All right. There you have it, and that's it for this problem.